Okay, we're live. So this is the lesson 4. I think we're calling it lesson 5 in limits for my 40S or 45SH students. And this is how we get what we're going to call Formula 1. And all we're really doing today is we're formalizing something we've been doing for a little while now, which is finding secants of curves and then shrinking the distance between the 2 points of the secant until it becomes a tangent line. So here's your everyday ordinary curve. I suppose it would probably be a cubic. And let's say that we wanted to know the slope at some point. We'll call it point P. And point P has coordinates of, we'll call them A and F of A. And I pick some sort of mystery point. We'll call it point Q perhaps. And Q, of course, has coordinates X and Y, which, F of X, same thing. And I would like to know the slope of the secant line. So the secant line is, of course, the line that connects, pretend that's a straight line, would you? That's, of course, my secant line from P to Q. And basically, what we've already learned, hang on a sec. Hi, can you hold a sec, please? Sorry about that, everybody. We're back. And seems to be working normally. There we go. Okay, so there's the secant line from Q to P. And what we want to do is we want to, of course, just imagine that point Q is going to slide that way and get closer and closer to point P until it becomes an actual tangent line. Let's see if I can draw a tangent line. Oh, that's pretty good. So this is, of course, is the tangent at point P of the curve f of x, whatever that curve is. And again, it's some sort of cubic. So note-wise, let me make this maybe one step smaller here. Note-wise, to approximate the slope at tangent P, we need to actually use the slope formula. So the slope formula is, of course, y2 minus y1 over x2 minus x1. And our coordinates are, of course, right here, right? We can call this one y2 and x2, and we can call this one x1 and y1. It doesn't really matter what order you do them in. So that's going to give us a slope of f of x minus f of a, that's an a, all over x minus a, right? But of course, as Q gets closer and closer to P, the x coordinate of Q gets closer to the x, that's an x, coordinate of P. So looking at the picture, right, this is the x coordinate right here, this is x, and of course down here this would be a. So as x gets closer and closer to a, this dotted tangent line here gets closer and closer to being the actual the dotted secant line gets closer and closer to being the solid tangent line. So if we could approach point P by moving Q closer and closer, the secant would eventually equal the tangent. We would say then that as x approaches a, and write the formula, that the slope of the tangent is the limit as x approaches a of f of x minus f of a all over x minus a. Now, I actually did try my best to make this situation from the notes here that on Desmos. Let's see if I can find that. Desmos, there it is. As you can see, I just kind of made up a cubic. And of course, this is the situation, right? Right now, that's a secant line. But the closer I make this point to point P, the closer and closer this gets to being an actual tangent line. Of course, I can't actually just put point Q onto point P, because as you can see, notice that then the slope would be undefined if a and x are the same number. But if I can get infinitely close, it turns out that the x coordinate here is 10. what if I get really, really close? Like what if it was 9 or 9.9 or 9.99? The closer and closer I get, it looks like to me this slope is approaching like 1.846 or 467 or something. And adding more digits just gets it closer and closer to some limit value. So now we're going to look at how we calculate those limits algebraically, because we've already learned how to do limits. So here's example 1. Find the slope of the tangent line at the point 2,7 on that curve. So here's how we're going to start that. We're going to go, whoops, get the pen going here again. We're going to go A. There we go. We're going to go A. And we're going to say that the slope of this curve is the limit as x approaches A of f of x minus f of A all over x minus A. And let's plug in what we know. We know that this point here is A comma f of A, or A comma, or xy, which in this case is A and f of A. And this is, of course, f of x. So I am looking for the limit as x approaches this A value of 2 of the function x squared plus 2x minus 1. And then f of A is just this coordinate here. Now, if it had just said at the point when x is 2, I'd have to run 2 through this formula and find that it's 7. But it tells me that it's 7, so I can just plug the 7 into the formula. So again, just in case, just to make sure you're following me, this part is right here, and this part is right here. Okay, so make sure that makes sense to you. And x minus A is, of course, x minus 2. And here's where we have to do limits the way we've been doing them in class. If I just plug in a value of 2 for x, well, the problem is I'm going to be dividing by 0. And in math, you can't divide by 0. So the limit as x approaches 2, first let's simplify that by collecting like terms. And then we have to see if there is an algebra method we can use that'll cancel that denominator, because right now we can't plug a 2 into that denominator. And it looks to me like I can use my factoring techniques, because the numerator factors into x minus 2 and x plus 4, which means those factors cancel, which means it's the limit as x approaches 2 of x plus 4. Come on. And that means that I can just, now that I've eliminated the denominator, I can just plug in the 2, and I get 6. So that's the A question. It said find the slope. I found it at 6. For the B question, it actually wants the equation of the tangent line. And you'll remember from grade 10, you can find an equation of a line if you know the slope and a point using the point slope formula. Y minus y1 equals m times x minus x1. And my x1 and y1 here are the 2, 7. And my m is the slope I just found, which is 6. So y minus 7 equals 6 times x minus 2. Now, most of your questions in your textbook want the slope as a standard form. So let's move everything to one side and say that 6x minus y minus 5 equals 0. And that should do it. Let's see if that's true by running that through Desmos. So if you haven't seen me do this through Desmos, this will be a nice little tutorial for you on how to use Desmos. Okay, so let's see. We're going to just get a new file here. Don't want to use that one again. Okay, so when you open Desmos, you just open the graphing calculator, and you start by putting in the function. And being slow here, there we go. So you start by putting in the function. So f of x equals, and let's see, what was it again? It was x squared plus 2x minus 1. So it's your standard parabola, and we have a point on that parabola that we want to find the tangent at, and that's the point P is 2, 7. Oh, hang on. That's not working. There we go. P equals 2, 7. There we go. And we can label that point if you like. And then we would like to find just any point on here. We'll call it point Q. And Q is going to have I can't use x again because x is already defined, so I'll use A. So A is going to be the x value, and f of A, which the computer will know to to just take whatever the a value is and run it through there. It's going to ask me, since I've introduced a third variable, if I want to make it a slider. And I'm going to say, yes, please make that a slider. So I'm going to click on give me a slider. And that allows me to move this point wherever I like. So there we go. I can move it to wherever I like. And I can label it. Of course, we've kind of labeled point Q as being x comma f of x. And there we go. So now, as I make this closer and closer, I need a slope value. So the slope value is going to be f of a minus the 7 all over a minus 2. And there we go. And as you can see now, the closer I move this point to 7, so let's see, right now the a value is, or sorry, the closer I get it to 2. Right now it's 1.46. What if it was 1.5 or 6 or 7 or 8 or 9 or 9? You can see that we're getting very, very close to that 6 number. The more 9s I put on, the closer I get, until you get to the point where the computer can't calculate it anymore. Then it will start to mess up. But up to about 4 or 5 decimal places, you can see we're getting infinitely close to that slope of 6. And if you want to actually see if the equation you got is right, so we got the equation 6x minus y minus 5 equals 0, right? So let's see if that looks like a tangent line when we go through there. So we'll go 6x minus y minus 5 equals 0. Oops, that's supposed to be a 0. And as you can see, yep, that looks very much like a tangent at that point. Perfect. So there we go. So there's the first example done on Desmos, just to check that we did it right, which we did. Okay, let's look at the second example. Find the slope of the tangent point at the point 2, 1 on the curve f of x equals 1 over x. Okay, so this is a curve that is not going to be a parabola. I still use the same formula though. The slope is the limit as x approaches a of f of x minus f of a all over x minus a. And that's going to equal the limit as x approaches, okay, so this will be a and this will be f of a. So x is approaching 2, that's an a. And f of x is just the function itself, so that's 1 over 1 minus x. And f of a we actually know is negative 1. Again, sometimes they don't tell you that. You have to figure that out for yourself. And once again, if I plug in my limit of 2, I'm going to have a problem. So I got to once again reach into my toolbox of algebra and figure out a way to cancel the x minus 2. So I think what I'm going to do is I am going to use my fraction skills. I'm going to get a common denominator here. First of all, maybe I'll tidy this up. This is 1 minus x minus a negative 1 is plus 1. There we go. Now I'm going to times top and bottom of this number 1 with the common denominator 1 minus x. I'm going to use the property of 1s and my fraction knowledge to simplify this into a single numerator, which would be 1 plus 1 minus x all over 1 times 1 minus x, which is just 1 minus x. Okay, now that's not looking great yet until you realize, oh, and I don't want an equal sign. I don't know why I put an equal sign between those. Don't do that. There we go. Equals the limit as x approaches 2 of, let's see, so that's going to be 2 minus x all over 1 minus x all over x minus 2. Okay, now there are 2 algebra tricks I can use on this. I don't know if you see this move or not yet, but if you factor a negative 1 out of here, then it's the same as that denominator there. And the other trick is, remember when you're in fractions, if you divide by, if you're dividing when you're in fractions, it's the same as multiplying by its reciprocal. So I am going to multiply by the reciprocal. And look at that. Those 2 factors cancel. Why don't I factor a negative 1 out of the bottom as well? Then that gets rid of that pesky negative that I'm bound to forget about because I'm a forgetful kind of a guy. There we go. Let's move back up to the top here. So that's the limit as x approaches 2. So it's the limit, come on pen, oh, my pen disappeared. The limit as x approaches 2, that's an I, of 1 over x minus 1, right? Isn't that what it was? Yep. Okay, so now I can plug in the 2, no problem, because that won't create a denominator of 0. 2 minus 1, which is 1. So the slope is 1. let's do the B part of the question now. The slope is 1, and I have the point 2, -1. So y minus y1 equals m times x minus x1. So that's going to work out to be x minus y minus 3 equals 0. And once again, let's go to Desmos and double check that that looks good. So let's just change up the graph that I already had. So, okay, what's different about this situation? I don't want to have to repunch. Oops, oh my word, what happened there? There we go. I don't want to have to repunch all this stuff. So let's just go up and change the equation. So the equation is now not that anymore. It's 1 over 1 minus x. It's not the 0.27 now. It's the 0.2 -1, which changes this f of this y value to -1, which means that it's +1. And that's about it. And now let's see. There we go. Looks pretty good. The closer a gets to 2, the closer... Oh, wait a minute. That's the wrong equation now, obviously. There we go. Okay, so now the closer that my point Q gets to here, so right now it's like infinitely close. Let's back it up a little, right? So there's the equation. So the closer that it gets, the closer I get to a tangent line. And by the way, if you actually want to make the secant line, you can. It's actually not that hard. You can go y minus f of a equals the slope, which I have defined right here, so the computer will know which one I'm talking about, and then x minus a. And as you can see, oh, whoops, I meant a, not q. There we go. As you can see, let's make that a different color. That's kind of unfortunate. It's the same color as the graph. Let's make that blue or something. There we go. So, as you can see, the closer I get, the more of a secant it is, the further away I get, and the closer I get, the more it becomes a tangent line. And let's get it as close as we can. Let's make that 1.99 or something. 999, there we go. And then let's see if the graph of the line we got is the same. It's x minus y minus 3 equals 0, and look at that. Once again, it's the same color, which is very unfortunate. Let me change the color on that one now. Change that to something like green. How about that? There we go, green. So, is the green line the same as the blue line? Green line, blue line, pretty much bang on. It's the exact same thing. So we've got it. Okay, one more example. Oops. There we go, example 3. Now we've got ourselves a square root curve, which you should remember is basically half a parabola. So it's going to look something like this and something like that. And we want the tangent equation right there. So we want the tangent, so we want the equation of that line. So let's see if we can find that. First we need to find its slope, and slope is the, oops, come on pen, is equal to the limit as x approaches a of f of x minus f of a all over x minus a. So that would be the limit as x approaches, my a value is 2, of f of x, which is square root of x plus 2, minus f of 2, which is 2, all over x minus 2. And then we check, can I just plug in the limiting value? No, that creates a divide by 0. So what can I do algebraically? I can multiply by my conjugate. And that's going to give me the limit as x approaches 2 of, FOIL that out, you get x plus 2 minus 4. I'm not going to bother multiplying this denominator out, because remember, my goal is to cancel the factor I just wrote down. And there we have it. The numerator actually will cancel that. That should be a 2. Because the numerator actually works out to x minus 2. So those cancel, and I now have the limit as x approaches 2 of 1 over square root of x plus 2, No problem plugging the 2 in now. So that's 2 plus 2 plus 2, which is 1 over the square root of 4, which is 2. So I get 1/4. So there's the a value, there's the a answer done. I know I have a slope of 1/4. For b, I would like the equation of the tangent line. So my slope is 1/4, and I have the 0.22. So y minus 2 equals a quarter times x minus 2. If it only wanted the equation in point slope form, you could say you're done. But again, most textbooks prefer standard form answers. So let's multiply both sides of the equation by 4 and then move everything to the other side. So that'd be plus 6 equals 0. And once again, let's check that out on Desmos and see if we did it right. So on Desmos, so this is no longer my function. My function is now the square root of, what was it, x plus 2? X plus 2. And the point wasn't 2, negative 1, it was 2, 2, which means that this should be a minus 2 down here for the slope. Come on. There we go. And there we have it. Oh, look at that. It's already pretty much set up. It's almost the quarter that we said it was. Of course, this is not the right equation anymore. Let's put the right equation in and see how good we are. We wanted the equation x minus 4y plus 6 equals 0. And as you can see, look at that. It's green, it's blue, it's green, it's blue. They are almost identical equations, and I'm only really accurate to 3 decimal places here. So there we go. That's Formula 1. Check out the blog, and there's some homework for you to practice.